I'm going to solve this integral by first splitting it into three different integrals. So I'm going to go ahead and split it into three different integrals. I is going to be the integral from 0 to the ln of 34 of 2 dx, right, plus the integral from 0 to the ln of 34 of 1 over 2e to the x minus 1 dx, plus the integral from 0 to the ln of 34 of 1 over 3e to the x minus 1 dx. Cool. All right. So the first one is actually very easy. So this is just 2x. The integral from 0 to the ln of 34 plus. So what I'm going to do for the second and the third integrals, I'm going to multiply the top and bottom by e to the negative x. So I have 2e to the x minus 1, right? And I'm going to add that here. That's the third integral, and that is going to be 3e to the x minus 1, like this. So there is the x here and then the x here. So what I'm going to do on top is to multiply this one by e to the negative x and then nullify the effect by multiplying at the bottom e to the negative x, nullify the effect e to the negative x at the bottom. Alright, so this is what we have for the second and the third integrals. And now plugging in the limit for the first one is going to be 2 times the ln of 34 minus 0, doesn't matter, so that is going to be the integral from 0 to the ln of 34 of e to the negative x dx. This is divided by this one multiplying, that is going to be 2 minus e to the negative x. Alright, plus the integral from 0 to the ln of 34 of e to the negative x dx, and at the bottom that is going to be 3 minus e to the negative x. Alright, so now we are going to do a substitution for the second and the third one. We are going to let u to be equal to e to the negative x. Alright, so when we do this, the u is going to be negative e to the negative x dx. So it means an expression for e to the negative x dx is going to be negative du. So these ones I'm going to replace them with negative du. Alright, the change in limits. When x is equal to 0, the lower limit, we have u to be equal to 1. That is e raised to the power 0. And when x is equals to the ln of 34, u is going to be equal to e to the negative ln of 34. So applying the power rule of logarithm, this is the ln of 34 raised to the power negative 1, and this is 34 raised to the power negative 1, because this and this will cancel, and now it's left with 1 over 34. So the upper limit for u is 1 over 34, and now the integrals in the u world is looking like this. This one, applying the power rule of logarithm, that is going to be the ln of 34 squared. It will be useful later on, plus the integral from 1 to 1 over 34. Those are the limits for integration for the variable u, and now e to the negative x dx is negative du. This is divided by 2 minus u, plus the integral from 1 to 1 over 34 of negative du, and this is divided by 3 minus u. Alright, so these ones are now very simple. So I here is going to be equal to the ln of 34 squared plus the integral from 1 to 1 over 34. This one I'm going to write it as du, and the negative is going to cancel because I'm going to reverse what is in the denominator, and it is u minus 2, plus the integral from 1 to 1 over 34, and this is now positive du divided by u minus 3. So now those ones are now trivial. So that is the ln of 34. This is squared, and now plus the differential of this one is the numerator. This is the numerator. So when we differentiate them, we get the numerator. So this is just the ln of u minus 2. That is the integral. And this one is going to be the ln of u minus 3. The limits of integration from 1 to 1 over 34 for both of them. Alright, so now let's try to simplify what that is and then plug in the limits. So the ln of 34 squared, and now plus applying the product rule of logarithm. Ln of this plus ln of that is going to be the ln of the product, u minus 2, and this is multiplied by u minus 3, like this. The limits of integration from 1 to 1 over 34. So far so good. I is going to be the ln of 34. This is squared, and now plus the ln. Let's multiply that. That is going to be u squared minus 5u plus 6, right? So this is what we have. Alright, so after doing this, then we can now plug in the limits of integration from 1 to 1 over 34. Alright, shall we? So I is going to be equal to the ln. The calculus is down here. Ln of 34 squared, and now plus, I'm plugging in the upper limit. So the upper limit is going to be the ln of what? 1 over 34. This one is squared minus 5 times 1 over 34 plus 6. All this one in the ln, and now this is the upper limit. What about the lower limit? The lower limit is going to be when you plug in 1, that is going to be this is 1 and this is 6, so 1 plus 6 is 7 minus 5, and that is 2. So the lower limit is going to be the ln of 2, like this. Alright, so I is equal to the ln of 34. This is squared, and now plus the ln. The upper limit, we have to simplify it. This is the ln of 1 over, this is 34 squared, minus 5 times. So minus 5 times 1 over 34 is 5 over 34 plus 6 minus the ln of 2. Alright, so I is going to be equal to the ln of 34 squared plus the ln of, now applying the, let's put it here, the LCM here is 34 squared. So this one divided by 34 squared here is 1 minus, this one is going to be 5 times 34, and now plus 6 times 34 squared. This is what we have inside the ln minus the ln of 2. Now let's apply the rule of logarithm here, and that is I equal to the ln of 34 squared plus, this one is going to be the ln of, this is 6 times 34 squared minus 5 times 34 plus 1. This one minus the ln of 34 squared minus the ln of 2. I'm just applying the rule of logarithm here. Alright, so now there's going to be a cancellation. This one is going to cancel this one out nicely, and what you are left is this. I is equal to the ln of this one minus that is going to be the ln of 6 times 34 squared minus 5 times 34 plus 1, all this one divided by 2. This is the answer. And now the top one here, when you work that one out, that one simplifies to 6767. So 6767, and now the integral, the final answer to this integral is the ln of 6767 divided by 2, and this is the answer that MIT gave for this beautiful integral. So the ln of 6767 over 2. And that is how I solved this integral. If there is an alternative version to solving this, leave a comment in the comment section and let me know what you think. And if you really enjoyed the video, consider subscribing to Calculus Diaries and give me a thumbs up so that I'll continue uploading engaging tutorials on integrals. I thank you so much for watching, and I will see you in the next one. Bye bye.